All right, so next up, again, continuing with probability, but we're going to look at a different situation in that, well, I'm just going to read this, is that in many cases, there is more than one action or choice, which results in several outcomes. So that we're going to do what's called a tree diagram because they're a useful tool to organize and show all possible outcomes. And so what we're going to have here in this situation is multiple things or multiple events happening. So in this situation, the spinner below is spun twice. All right, so we're going to look at the sample space, which is all possible outcomes, and then we're going to find the probability of those things happening. Now, when I do a tree diagram, what that means is the first time I spin the spinner, three things could happen. I got an A, I got to get a B, or then I get a C. But then we spin this spinner again. Now, say if I spun the first time A, well, then the second time I could get an A, a B, or a C. The same thing could happen if I got a B first. The second time I could get an a B, or a C. And of course, repeat. If I spun a C first, I could get an A the second time, a B the second time, or now a C the second time. So that's what a tree diagram looks like. Now, how it helps us out is when I'm dealing with my sample space. Now, again, your sample space is all the possibilities that you could have. And so off the first tree branch, I guess you could say, I could get an A and then an A. I could get an A and then a B, and then I could get an A and then a C. Now, off the second part of our branch, where we get a B first, I could get a B and then an A. I could get a B and then a B. I could get a B and then a C. Now, in the third part of our branch, where you get a C first, you could get a C and then an A C and then a B, and then you could get, well, two C's. And that is our entire sample space, all the possibilities of what we could get. All right, now that will help us figure out our probabilities because it says A, what is the probability of getting a B twice? And I look and there's only one situation where that happens. And again, to figure out a probability, I look at how many possibilities there are. And let's see, I count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. And so if I convert that to a percent, 1 divided by 9, again, times it by 100%, it is 11.11% that can occur. The next up, B, the probability there's at least one A. All right, well, again, I know there's going to be a 9 in the bottom because there's 9 possibilities, but at least one A. Let's see here. 1, 2, 3, 4, 5, 5. That's it. So 5 out of 9 chance. And again, as a percentage, I take my 5 divided by 9, times it by 100%, and this time I get 55. We're getting rounding to 2 decimal places here, 0.56%. Right now, C. What is the probability we get no C's? Okay. Again, there is 9 situations here. No C. There's 1, 2, 3, 4, and that's it. 4. And again, as a percentage, 4 divided by 9 times by 100%, and this time I get 44.44%. And there we go. So again, drawing a tree diagrams helps me sort out what is possible, and then it allows me to easily do my sample space and then figure out my probabilities. So I'm going to do a couple more of those. Number 2, the popcorn stand offers buttered or unbuttered popcorn. but in three sizes: small, medium, or large. All right, so we're going to look at coming up with a tree diagram. Now, the first choice you have to make when you go to this popcorn stand is you get, let's see here, buttered. Hold on, we'll draw some branches here. You're either going to get buttered or unbuttered. That's your first choice. But then after you make that choice, you got to pick your size. So if I get buttered, I got to pick between a small, a medium, and a large. Same thing if you went with the unbuttered. You got to choose between a small, a medium, or a large. So there's our tree diagram. Now, our sample space. Again, that's where we have my funny looking brackets. Let's see, we'll go down the buttered route. That's my route anyways. That's what I'd be all about. Same with my family. I could get a buttered and then a small, buttered then a medium, or a butter then a large. You go the unbuttered route. Unbuttered and small, unbuttered and medium, or unbuttered and large. And there's our sample space. So there is, let's see here, 1, 2, 3, 4, 5, 6 possibilities. All right, now figuring out probabilities. What is the probability you get something that's buttered? All right, well, I look. Again, there is 6 possibilities. And there is how many butters? 1, 2, 3 of them. And so as a percentage, well, 3 out of 6 is half, which I don't even have to use my calculator here. There is a 50% chance that somebody picks buttered. How many probability people pick large? Well, again, there is 6 possibilities, and I look for the amount of larges. 1, 2 of them. 2 out of 6 of those possibilities are larges. And so again, converting that to a percentage, 2 divided by 6 times 100%, I get 33.33%. All right, let's see here. C, the probability that we get a small with no butter. Okay, so again, there is 6 possibilities. Now, how many are small? No buttered. Not this one. These are all buttered, so they're all gone, the first 3. And unbuttered and small. There's only one way that's happening. All right, and again, converting that to a percent, 1 divided by 6 times 100%, I get 16.67%. And there we go. So again, there's our tree diagram, sorts things out for us. And again, that allows us to come up with our sample space, which then helps us, again, find our probabilities. All right, let's try another one of those guys. Let's see, I'm going to skip. There we go. All right, so we'll go with number 4 here. All right, number 4. Do I want to do number 4 or number, let's see. Yeah, number 4. A day of the week is chosen at random, and then a coin is tossed. All right. So let's start off with the first selection here. A day of the week is chosen at random. All right. So with days of the week, the first part of our tree here is you got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and you got Sunday. So there is 7 options, clearly, if you know the days of the week. 1, 2, let's see here, 3, 4, 5, 6, 7 branches to start off. But then within each day, we toss a coin. So you could have a heads, tails for each day. Heads, tails, heads. Whoops, tails. Try to slide those in there. It's getting a little bunched up. Heads, tails. Again, for each day, it's a big tree here, a lot of branches, heads and tails for each of these days. Heads, tails, and Sunday is heads, and we got a tails. All right, so quite a bit of branches there, which means then when we do our sample space of all the possible outcomes. Again, that's where we got our squiggly brackets here. So let's see. The first branch here, we have Mondays, then heads. We got to have Mondays, then tails. Then we go, let's see here, Tuesday, heads, and then Tuesday, tails. Next up, we've got Wednesday, then heads, and then Wednesday, tails. Next one, Thursday, heads, Thursday, tails. Then, of course, most of our favorite day there, Friday and then heads, and Friday then tails. And then we got our weekend, Saturday, then heads, Saturday, then tails. And then lastly, the last branch, we've got Sunday, then heads, and then Sunday, then tails. And that is our sample space. And so we have, let me see here, count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 possibilities. And so the first one here, we're going to look at the probability that you get tails. Well, there is 14 possibility. Now, how many have tails in there? I got 1, 2, can't get confused by the days here, 3, 4, 5, 6, and 7. And again, converting that to a percentage, well, 7 out of 14 is half, 50%. 50% chance you're going to get tails. Don't care about the day. Now, next up, the probability you get a day that starts with a T. All right, so again, we have 14 total possibilities. Now, how many times do we have a day that starts with a T? So we've got, let's see here. And again, don't get your tails mixed up because I put TU for Tuesday and TH for Thursday. So I got 1, 2, let's see here, 3, 4 possibilities. That's it. So 4 out of 14. Again, convert that to a percentage. So 4 divided by 14 times 100%. We've got 28.57%. C, a probability that you get Friday, then a heads. All right. Again, there's 14 possibilities. Let's look. When you get Friday and a heads, well, there's Friday over here. There's only 2 of them, and only 1 of them where you get heads afterwards. And so there's only a 1 in 14 chance. It's pretty specific. So again, 1 divided by 14, and then times that by 100%, and there's only a 7.14% chance that you get exactly Friday and then a heads. All right, so there we go. Again, coming up with our tree diagram, quite a few branches here, which allows us to do our sample space, and then we can figure out our probabilities pretty quick. Now, something we're going to look at, let's see here, moving ahead here, is what's called the fundamental counting principle. All right, so you can use the counting principle to find the total number of outcomes a lot easier, all right, without drawing a tree diagram. Now, a tree diagram allows you to easily come up with a sample space and find probabilities, but you can figure out the total number of outcomes because if one activity can occur in, say, X number of ways, and another activity can occur in, say, Y ways, then both activities can occur in X times Y ways. All right, so for example, I'm going to go back to our last example that I just did, is that a day of the week, there is 7 days of the week. And when you toss a coin, there is 2 possibilities. And if we multiply 7 times 2, that gives us our 14. So we didn't have to count them all out. Again, this is just to find the total number of outcomes. Now, in this case, let's see example number 1. To leave her office, Karen can choose between 3 sets of stairs and 7 doors. How many ways can she leave her office? Well, there are 3 sets of stairs And we're going to multiply that by the fact that she's got 7 doors she can choose. And so how many ways she can leave the office? Well, 3 times 7 gives us 1. Now, again, that's just the total outcomes. It's not giving us our sample size or anything. Number 2, a sweater comes in 4 sizes and 8 colors. How many different sweaters are possible? Well, again, there is 4 sizes you got to pick from. Then there's 8 colors. So 4 times 8, there are 32 different sweaters. All right, a couple more here. A class has 11 boys and 16 girls. How many ways can the teacher choose one boy and one girl? Well, you've got 11 boys you can choose from. And let's see here, you've got 16 girls. So 11 times 16, which is, let's see here, I can't do that one in my head, 176 possible ways that you could choose. Tough sledding for a teacher. Let's see, a couple more here, and then we'll finish it up. A dinner menu consists of 5 appetizers, 12 entrees, and 3 desserts. How many ways can someone order 1 appetizer, 1 entree, and 1 dessert? So now we got 3 different choices. All right, but to start off, you got 5 appetizers you can choose from, 12 different entrees, so that's your dinner meal. So times 12, and then dessert. You got 3 choices. So this time we're going to take 5 times 12 times 3. And so you've got 180 different options to eat dinner. All right, last one. A card is chosen from a standard deck. Then a die is rolled. How many possible outcomes are there? Well, something I've talked about many times is that a card is chosen from a deck. There are 52 cards. And then a die is rolled. Well, you've rolled dice, a standard die. There's only 6 of those. And so the possibilities, let me see here, are 6 times 52, and we get 312 possible outcomes. So again, just using the fact that we can count using multiplication, that helps us count the amount of possible outcomes that are on our tree. But again, it doesn't tell us the sample source that we could possibly have, and helps us figure out the probabilities. But it does allow us to figure out the possible outcomes fairly quickly. All right, so oops.